So this is how the app works. The first thing we want to do is import our sensor data. So let me do that right now. So our app will display the orientation sensor data over time on a graph. So pitch, azimuth, roll, you can all see how it varies over the course of the recording. And then the same thing with angular velocity. We also have a table at the bottom which will show the exact data of every value at every timestamp for the entire sensor data recording. I also have a create CSV file here, so it does exactly that, and you can name it whatever you want, and save it wherever you want. So I have upload to ThinkSpeak channel, so that it will take this orientation and angular velocity data and upload it to ThinkSpeak. We have show initial and final phone positions, so as you can see, this will only work if the phone pictures file is saved to this directory, and make sure it is so. If you want to make sure it is, you can press cancel, or if you know it is there or you already looked, you can press OK. Then there's just some info here, so the initial and final phone position will be rounded to the nearest 90-degree angle. For simplicity, the left image shown will be the initial and the right is our final. So you can see that the initial phone position approximately look like this, the final phone position approximately look like that. Finally, we also can import data from ThinkSpeak. So what this does is it will take the 3 most recent data uploads from ThinkSpeak, and then it will determine how many times the phone was dropped of those 3 values. So in this case we have right here, the phone was dropped twice, or maybe 2 phones were dropped in our past 3 data samples.
So all of the data is imported just with this one import sensor data button. So I will view the callback from there. So here's the import sensor data pushed callback function. So for here, the first 5 lines about, just locate the .mat file that you're using. So this is the code that you do. That UI-get file is the function that finds the .mat files, and it saves them to the one file name variable and one location variable. And this is just used just to get the data. This is just one of the standard multi-line functions that is required to receive the data points within the MATLAB app. So as you can see earlier, we needed to create some global functions so that we can use them within multiple callbacks. So new data 1 is just our code name for, or our variable name for all of the data that we get within the mat file that we're from the sensor data file. So from after that, all we do is we create the different graphs, the x and y axis. So the x roll is just new data dot orientation dot timestamp. So we just use dot notation to get the part of the times table that's just the timestamps. So that's the x-axis. And the y-axis is obviously just going to be the same thing, but instead of timestamp, it's just going to be the z orientation. And the same is for the next 2 tables, or the next 2 graphs, which is pitch, azimuth, and roll. So that's just x, y, and z, as you can see here. For the next one, we needed to do the same thing with orientation, but obviously with just angular velocity. So this is the same logic here, where we set the y-axis, we set the x-axis, and then we just plot it, and then we set limits here, which is so that you can see how high and how low, because we don't want to show too much. So it goes from -180 to +180 for the roll, azimuth, and pitch, because it's an angle, so that's as high and low as it can go. So we're just trying to set the limits logically. And after we set all 6 of the graphs, then we just set the table, which is fairly simple. We just use one function, which is we have our global variable, which is tt hourly, which is just the times table that is going to include the linear interpolation of to fill in the data points that we don't have, because you can't effectively sync all of the different graphs and sensor data into one table without having some empty frequencies. So we needed to fill that in with linear interpolation, which is part of the synchronize function. So once we have that, it sets this to a times table, which is just all of the data from angular velocity and orientation synced up together. And then we just set the times table to table right here with a simple function. And then we set the UI table to that, which is the same for all these. So we're essentially just plotting it, but with the table. And that is essentially how we got the core component working.
Okay, so my main contribution to the final project was everything dealing with the functionality of ThinkSpeak in the reach component. So here I have this sensor data already imported. It's new data. I just took it just now. And if you look, here's our ThinkSpeak channel. We have 4 fields, and the most recent data uploaded was from June 2nd, and today's June 8th. So I'm gonna go ahead and upload this new data I just took using this button right here. And it should be good. If we go back here, reload the page, here's the new data just uploaded. It takes the maximum and uploads the maximum value found on each of these graphs to ThingSpeak. So that would be this value right here, this one, and this one. And it also takes an average of all of the maximum values, and it uploads that as well. So that's these right here. And then what we do with this data uploaded is we have a thing tweet functionality. And here's the React command for that. Basically, here's the condition. If in this channel, the average angular velocity, so that's the average taken from the x velocity, y velocity, and z velocity, is greater than 10, thing tweet will tweet, oh no, I dropped my phone, using this Twitter account. And if we check on the Twitter account right here, the last one was from June 2nd, and so we should be getting a new one now if I reload the page. And yep, there it is 1 minute ago. Oh no, I dropped my phone, facepalm. I'll go ahead and show the code that was written for all of these functionalities. This is for, this is the callback function for uploading to ThingSpeak. We have our write channel ID, our write API key, and this is taking the max of each of the graphs that we have for our angular velocity. And then it also takes an average right here. Okay, and then we have the ThingSpeak write function, which takes the write channel, all of the max and the average, our write API key, uploads it to fields 4 through 7, and it also uploads the timestamp. And then down here is for importing data from ThingSpeak. We have the ThingSpeak read function. This sets it to a table. And then we have this code right here, which finds how many phones have been dropped since a certain date. And this puts it in string format.
So this is how the initial final phone positions work. So I take the global variables of the data that you uploaded into the app. I take the first value and the last value, which will give us the initial and final position of the phone for roll, pitch, and azimuth. I put them into an array just so they're easier to access. And then to keep things simple, I have this for loop here which goes through the array and changes the values to the nearest 90-degree angle, so 0, 90 degrees, 180 degrees, or negative 90 degrees. I then have this code here, which is just to create the warning window and then the info window. Here I add a path, which is how we will read the image files, and this is why the phone pictures folder needs to be saved to that location, because this is how the app will find the phone pictures. So for the initial phone picture, I created a string, that's the name of the image, and all of them have the same format, so it's easy to go through. So it starts off with pitch, a value, and then roll, a value, and then azimuth, a value. So we start with pitch, we take the initial pitch value, we put it in a switch to see which value is correct. So let's say pitch is 0, it will see that 0, and then we change the string to be the string plus the 0, and then add the roll, which will be done in the second part. And it goes through the same thing with the roll, and then the same thing with the azimuth. For the final phone position picture, the exact same setup is done, but this time we use the second row because that's where the final values are held. So we go through that, and then at the end I use imRead and then just the name of the image, which is the string we have built through the switch cases, and then I use subplot and image show to show the pictures.